The broadcast is now starting. All attendees are in listen-only mode.
All right, hi everyone. Welcome to vBrownbag US. Sorry, we're a few minutes late here, but as always, we all have to deal with customers and things like that. So we're continuing on our VCP6 series here. If you would like to follow us on Twitter, go to @vBrownbag or @vBrownbagLatAm or @vBrownbag EMEA, depending on which region you're in. For the purposes of the show, you can always hashtag vBrownbag to ask questions and things like that. You can also ask questions if you're actually attending the meeting in the GoToMeeting as well. A few other show notes. For those of you in the APAC region, tune in to vBrownbag every other Thursday, 9 p.m. NZST. And if you're in EMEA, follow us every Tuesday at 7 p.m. BST. In Latin America, Thursdays, 7 p.m. Pacific. And of course, our US Wednesday, 7:30 p.m. Central show. Tonight we have Walter Bentley, guest presenting for us. And then, of course, I'm Lauren Malhoit at Malhoit on Twitter, and Jeff Wilmington is also co-hosting with me. So with that, I'm going to pass it on to Walter so he can tell us some interesting things.
Well, thank you for that great intro. I really appreciate that, and I promise the background noise will go away in a matter of a minute or two. But thank you again, guys, for inviting me. I've actually been looking forward to this evening for quite a bit, and hopefully I can share some stimulating information about OSAD and OpenStack. So I guess we can jump right into it. You kind of covered who I am in the intro there. Walter Bentley. I'm relatively a new racker, in my opinion, even though I've been there for a year now. And I've enjoyed this OpenStack journey. I am focused primarily as a private cloud architect. And what I do is I get the privilege of sitting with customers and going through their cloud journey with OpenStack. And that's something that I've been doing for some time now and really enjoying myself. So what we're going to talk about tonight is deploying OpenStack with OSAD. And if you're not familiar with what the term OSAD is, that acronym, which is, I guess, relatively new, it basically means OpenStack Ansible deployment. So the idea of deploying OpenStack using Ansible. And we're going to talk a little bit about what Ansible is if you're not familiar with it. I'm assuming most of you guys are. But we'll go through some of that in a minute or two. So again, I won't give you the grueling details about me. Been doing this for about 17 years in IT. Started out as a developer, and these are just some. I pretty much have focused on support all my life. So
Hey, Walter, I think we're losing you. Your audio, anyway.
Not everybody is familiar with OpenStack. You may be new to it. You may be just getting started. But I just like to start out with a clear level set so that we can learn and progress together. So OpenStack, I would explain it in its simplest words, is it's an open source cloud computing platform. And what that basically in turn means is it's a platform, a cloud platform that you can actually install and manage on your own. And it has the flexibility of being able to scale horizontally, vertically, the capability of utilizing commodity hardware.
Walter, I think you're breaking up there.
I'm breaking up. Okay.
That sounds a little better now.
It's a little bit better?
Yep.
Cool. Okay, good. Sorry about that. So, yeah, I'm not sure we kind of left off that, but the idea that it doesn't require any sort of commodity hardware. You can use any hardware, whether it be open compute. You don't have to use OEM. And you can use something that's old that may be sitting in your data center. Those are all opportunities where you can deploy OpenStack to. And what the biggest piece of OpenStack that stand out to me is that it's API driven. So everything about the platform is driven by an API. And I call it OpenStack a hypervisor manager because the common misunderstanding about OpenStack is that it's a hypervisor, and the reality is it's not. It is meant to manage multiple types of hypervisors, whether it be Hyper-V, Xen, KVM, of course, VMware, and even Docker as a hypervisor. So there's a lot of opportunities out there on OpenStack, and you probably see
Walter, it's happening again, I'm afraid.
Okay, is this better? I'm literally going to not move from this physical spot. Is this better?
Yeah, I think so.
No problem. So kind of moving along. So kind of break to its actual individual services or products that make up OpenStack. This diagram is something that this picture here is something that I use a lot of times when talking to customers, which kind of gives them a level set as to what they're dealing with. I like to show the code names of the projects as well as the names that the OpenStack Foundation has given them. Becoming familiar with the code names is actually very helpful. You'll find that there's a lot of documentation from OpenStack that will use the code names, so I like to put them there and put some color to them to kind of help you remember them. But I won't go through each of these in detail. It's a figure that would definitely take up too much time. But these are currently, right now, the core components that make up OpenStack. With every release, every 6 months, of course, there may be a possibility of a new project being started, or some of them in an incubation period. But these are just some of the ones that I currently highlighted that are deemed as, with air quotes, production ready, so to speak. Just kind of speaking about the community that builds up OpenStack, and I can already tell you that these numbers here are already stale because the numbers of individuals and the numbers of companies that join the OpenStack community grow on a daily basis. And so these numbers here are clear indications that OpenStack is something that individuals are very interested in, and that there is a very active community around OpenStack. And the one part that jumps out to me that I've always think is amazing is that it's 20 million plus lines of code make up OpenStack. That's just a phenomenal amount of code written by individuals who are volunteering their time to offer up a platform that everyone can use on their own. So I just think that that's a phenomenal number. So before, we're going to briefly talk about what Ansible is. If you're not familiar with Ansible, anyone who knows me or follows me on Twitter knows that I'm a huge fan for the very reasons that deep down inside I've always been a support admin, and again I wish that OpenStack and Ansible existed when I was doing that job. I would have had a lot more better evenings and a lot less sleepless nights. But Ansible is defined as an automation tool that can do various different things, whether it be configuration management, software deployment, whether it be application orchestration, and as I said there, basically replace your infrastructure guy, but not really, as you already know. The thing about OpenStack that Ansible stood out to me is that its goal and key message that the creators of Ansible shared was that they want to make the first and foremost, out of all things, is that they make a simple and a maximally easy to use platform. So when they created Ansible, they wanted to make it as easy as possible for a consumer to use. And that's something to me, simplicity is something very important to me, especially when you have a very busy life as the infrastructure support person. The key things of Ansible that stand out to me is that there's no agent needed, there's no daemon needed. Only thing that's needed to use Ansible is SSH, which, as anyone knows, on any Linux kernel, that is pretty much a default. It's installed or used to be able to manage your Linux environment. So all it needs is SSH, and with SSH, it's able to leverage all the capabilities there, as well as the modules that make up Ansible to do pretty much anything you want to that host or series of hosts, and just by simply executing one script. You probably have heard the term playbooks before when talking about Ansible. That's just basically the simple term used what they use to organize the code. Again, Ansible is written in a very easy markup language YAML. To me, it's almost like reading an email. It's not like learning a new language such as Python or Perl or even Java. It's very straightforward, markup language, and pretty easy to pick up. And that link at the bottom there is a link to Ansible docs. Definitely encourage you to take a look at that. The documentation out there I think is excellent, and I've looked at a lot of documentation in my lifetime, but I think it's straightforward. It has really good, useful examples, and I'm pretty sure you can definitely benefit from that. Again, links, some best practices around Ansible and about the modules that are available with Ansible. There's too many for me to name. There are specific modules that are created to just manage OpenStack. There's specific modules created to manage AWS instances, to do specific things in Linux, to do I can go on and on. There's just so much to talk about that. So definitely take a look at these two links. You will get a wealth of information, a wealth of knowledge from them. So this is where we kind of get into the details of the conversation that we want to have tonight. Talking about how the combination of OpenStack and Ansible just feels right. It's just a natural feeling. It's something that the community, OpenStack themselves, has realized is a great fit, and thus the reason how OSAD has become very popular and is now one of the standard methods of deploying OpenStack is the OSAD method now. So now we're going to get into the meat and potatoes. I dig into OSAD and how the thought process around OSAD came about and how it came to existence. So again, OSAD stands for OpenStack Ansible Deployment. And when it was created with three core principles in mind. And Rackspace, we were the ones to charter the waters and create OSAD, and then we turned it over to the community to be able to improve on it. And that's pretty much something that we feel very, very strongly about. You know, Rackspace is very strong about creating open source and being able to turn it over to the community for them to use it, improve on it, and us to collaborate together, and that's always our goal. But these three principles were the principles used when creating the OSAD installation. Stability, scalability, hybrid, and flexibility. And those three principles mean a lot to Rackspace in particular because when you think about it, we do have a product that is built, we do have a product that we offer our customers that is built on OpenStack. We call it Rackspace Private Cloud, built on OpenStack, powered by OpenStack to be exact. And the idea is we needed to be able to have a flexible way of being able to deploy OpenStack for multiple customers and multiple different private clouds. We needed to be able to scale out that footprint of their OpenStack very easily, very simple fashion. We needed the flexibility of being able to do this not just in our data centers, but as well as in the customers' data centers. And that's a very key point, is that the process we use to deploy OpenStack with Ansible or OSAD is the same process we use in our data centers as well as the same process we would use in a customer's data center. And then, of course, the idea of hybrid. You know, how can we leverage not just installing OpenStack, but also have something to do additional orchestration and configuration within your cloud? And Ansible is definitely the answer to that. Ansible, in its native form, in native fashion, does a great job doing configuration management, and thus the reason why that's something we looked at. And so far, we've heard very positive feedback. And at the last Vancouver OpenStack Summit, there was actually specific workshops designated just to talk about OSAD and what improvements can be made to it. So we're very excited about that. Now, I'm showing you this reference architecture. So I mentioned before, we obviously have a product called Rackspace Private Cloud on Open. I'm showing you this reference architecture, not a plug, but rather to show the complexity around OpenStack. With running an OpenStack platform, you're dealing with multiple control plane servers. You're dealing with additional servers to aggregate logs. You're dealing with n number of compute nodes. You're dealing with n number of sender nodes. You're dealing with Swift clusters. And we're talking about this. You know, these regions can grow up to massive amounts of nodes. So how can you take something so complex as this and such a large footprint as this reference architecture and make it simple? And that was very easily done by using Ansible to deploy OpenStack. So some of the key features and benefits of OSAD that I generally like to share with folks that I talk to about it is the first and foremost feature is the fact that it is Ansible. The fact that OSAD uses Ansible to me is a double win. Not only do you get to deploy OpenStack, you also get to learn another tool, and that's Ansible. So I think it's a two-for-one deal, and I do consider Ansible being a distinct feature and benefit of OSAD. The other distinct feature and benefit of OSAD is the use of Linux containers. And we're not talking about Docker, we're talking about, let's see, the original. OpenStack services
Walter,
are actually
we have some
deployed
static.
into Linux containers.
Oh.
Oh, is this better?
Yep. Thanks.
Yep, much better. Okay. Sorry. Okay. And I apologize for the connection. So when you deploy your OpenStack services, they're actually deployed in LXC containers. And you may, why would we take something simple and make it so complicated by using containers? Well, in reality, if any one of you have ever tried to upgrade OpenStack this version, and as I mentioned before, the community releases we're talking about 6 months.
Yeah, it's just getting worse, Walter.
So, is this better?
I believe so.
All right, this is better.
It's hard to tell. Nope, it's not better.
It's hard to tell. Okay.
Yeah.
Any better now? Sorry about this, guys.
Yeah, that's better.
That's better.
Yep.
I'm referring to the other Wi-Fi. I don't want to drop the webinar, but okay. So by deploying the OpenStack services in containers, it gives us the ability to be able to do in-place upgrades. So the idea is that when there's a new release such as Kilo, let's say, for example, you're running Juno right now, to upgrade, we would basically pull down the new Kilo containers. We would make the necessary database upgrades. We would basically turn off the current Juno containers and turn up the Kilo containers. And at that point, you're now running the Kilo release of OpenStack. And that's the advantages that we've gained from running the services in containers, as well as we're isolating each service from one another. God forbid you make a Keystone, you don't end up mucking up everything on that server. You can literally pull the Keystone container away and bring it down, download it again, and you're back to where you were before. So that's one of the major advantages and benefits of using OSAD. The other thing is that we're leveraging Linux Bridge agent instead of OVS, and some may see that as a negative, but in reality, through our trial and error and various amounts of pain with deploying OpenStack, we've found that OVS just didn't hold up to scale. And our main objective in offering it was to be able to have not just a production-ready cloud, but a highly available production-ready cloud. And in order to do that, we had to make sure that we were able to provide every single component we provided was able to sustain production level of load. So we did find that OVS was not able to do that successfully, and we found great success in pivoting back to Linux Bridge. So you're actually running with Linux Bridge agent instead of OVS as the ML2 agent for Neutron. And side note, as the next bullet point brings out, you will have a full Neutron deployment. So it's not running over networking. You will actually be able to leverage Neutron in its full extent, whether it be as a layer 2 or layer 3. So you will have VLAN and VXLAN capabilities within your OpenStack cloud if you go with OSAD. And as before, I mentioned within OSAD, OpenStack services that are included are only the ones that have been deemed as production ready by the community. And we do that because, again, as I mentioned before, it's very important to be able to provide production ready, highly available OpenStack clouds to our customers. And last but not least, which is my favorite one to talk about, is that with the OSAD deployment, you can do it in many different ways. If you want to do it all in one, just you can test it out or do it in a lab format, you can do that. Or if you want to deploy it in a fully multi-node OpenStack platform or OpenStack ecosystem, you can do that as well. You do not have to change the method. OSAD will be able to do one or both of those options. It's all about making adjustments in the configuration file and hitting go. And literally, you can switch between an all-in-one deployment or a fully distributed deployment. So again, I think that's a pretty fantastic thing.
Hey, Walter, did you
So
say that you might
now
be able
moving
to
on.
connect to a Wi-Fi by any chance? Because I think it might be
Yes,
worth
I would
it
just
to
have to.
do it. It's kind of in and out a lot.
Uh,
Are you there? Sorry, guys. Just a brief moment while we figure this out. Hopefully, we can make it a little better.
That's probably.
What was that, Jeff?
Graham posted in the questions. He said he probably doesn't want to update his iPhone during the webinar.
Oh, right. And now I'm not sure if we've just lost him at this point, or... Oh, it says he's offline. Okay. Trying to think of ways to vamp, but it's kind of hard to do when you can't see people.
Yeah, I was getting ready to maybe break into, let's go out to the lobby or something.
A little
okay, I'm
soft.
back now.
Oh, great. All right. Because Jeff and I were
Yeah,
about
I was
to
afraid.
start singing, so.
Yeah, I kind of felt that was coming, and as I was afraid to switch over to Wi-Fi for that reason, but so be it. Here we are, and sorry again. Yes, it's turning into a bit of a mess. I apologize, but kind of getting back to the fun of it.
Yep. No worries.
So,
And also
so
your
yes,
slideshow is not showing really.
is it showing now?
Yeah, I have to get to that. But you're coming in 5 by 5. Very well.
Yes, true story. I'm seeing your computer, but I'm not seeing the slide that you're on. You're supposed to be on. Is that just me? Is everyone else?
Let me see. Is that better?
Jeff, are you seeing the same? Here, maybe I can do something here. Oh, sure.
Yeah.
It's not letting me make you presenter. Okay,
It's already showing his presenter thing.
Yeah, but I just wondered if, yeah. Jeff, you're seeing the same thing I am, right? All we're seeing is like a new iPhone software version is available.
Yeah, maybe we flip it back to
Yeah, let me.
flip it back to his presenter.
Yep.
And then flip it back to him. Let's try that.
Okay, try it now, Walter.
So I'm sharing my main screen. I'm going to stop sharing my screen. I'm going to go back to showing my screen. Is it better now?
I'm not seeing it.
Oh, gosh.
I'm actually still seeing your desktop there, Lauren.
You're seeing mine? Change to the presenter. He's no longer on my list.
Yeah, I'm gone. It's like I'm a ghost right now. Okay. Let me do this. I'm going to leave and come back in.
Okay. Sorry, folks, just a couple more minutes.
Okay, I'm back. Can you try and give me presenter now? Can you guys see that now?
Yep, you're looking good.
Okay. Yeah, this is disaster 101. Okay, so yeah, I tell you.
This is vBrownbag 101. This is how.
Yeah. Oh, okay. Got it. So then I'm in there. I'm there. Okay. So I kind of stepped on and talked about this a little bit before, but the OpenStack community adoption, sometime back in the end of November of last year, the community voted to accept the playbooks that were written by Rackspace as the basic going method of being able to deploy OpenStack when using Ansible. So those playbooks and things we wrote are right there out on StackForge repository for anyone to use. So feel free to take a look. The code location is right here on the screen. Again, the playbooks that are here on StackForge are the exact same playbooks that we use to deploy private clouds for our customers. There's no difference. So definitely encourage you to take a look on the GitHub page. It means a lot to Rackspace, and we love the fact that the community now can contribute to the work that was started around OSAD. So we're going to really get under the covers now, and I have to make sure I'm not going to run over on time too poorly, but just want to talk a little bit more details around what is needed for OSAD, the high-level prerequisites, and maybe even show the 2 variable files that you'll need to fill out in order to deploy OSAD. And it's only 2 YAML files you actually need to update to actually do the deployment. And I think I'll probably pull those up and give you a show of those. So the high-level prerequisites of OSAD are actually pretty straightforward. The first requirement is running in Ubuntu 14.04 as an operating system. The next one is having SSH as a client on the machine deploying your cloud, as well as the machines that are going to be running your OpenStack cloud. NTP client, which is very important. Anyone who knows OpenStack knows that NTP is at the top of the list of prerequisites that you need to have to run OpenStack successfully. Python 2.7 or later, which pretty much is a standard. 2.7 is not too new of a version where you probably won't be running it. Most people are running 2.7 or later. And in order to use the networking features of the OSAD, you do have to create a series of bridges and namespaces in order to be able to leverage Neutron in its full capacity. And those bridges that need to be created are named here, and I'm not going to go into too much detail as to what they do. The instructions around OSAD actually go into a grave detail with diagrams and et cetera, explaining why those network bridges are needed. But very straightforward process, creating of non-routable VLANs that you then create bridges on your machines that are going to be running OpenStack. And again, that's getting into the much more advanced conversation when talking about Neutron and things of that nature. But these are the very high-level prerequisites you need to run the OSAD installation. And behind that, basically are 3 main playbooks that you need to run to deploy OSAD. And I know it sounds too simple to be true, but it really is true. And there's actually a 4th one that I'm including there as optional in the event that you wanted to run HA proxy to be able to balance the traffic across your 3-node control plane. Because with this OSAD deployment, it's not an active passive for the control plane. Each control plane server is actively being leveraged by having some sort of load balancing mechanism in front of them. So if you wanted to use HA proxy because, quite honestly, you didn't want to pay to have a physical hardware load balancer, you can surely run the HA proxy playbook that's written here, and it will actually configure HA proxy and have it all set up for you to utilize with your OpenStack cloud. But outside of that one optional guy, the host setup, infrastructure setup, and OpenStack setup, the YAML files, are the 3 playbooks that need to be run to install OpenStack. Host setup pretty much does the prerequisite stuff, making sure all the prerequisite packages are installed, making sure that
LXC is installed on the machines that are running the control plane, because again, it's going to be pulling down those cached LXC containers. It does all the pre-work to make sure your host is prepared and ready to actually install OpenStack. The infrastructure setup guide basically goes through and installs all the core infrastructure components that you need, such as MySQL, Galera cluster, RabbitMQ. With OSAD, you also get a full ELK stack as well. So the infrastructure playbook will install Elasticsearch, Logstash, Kibana, and as well do the rsyslog's configurations that are needed to be able to use that ELK stack. And the last but not least, which is the most important playbook of the day, is the OpenStack setup. That will actually go through and install all the OpenStack components one by one. And if you're come out the end with all successful and no fails, which is basically all greens and oranges per Ansible's coloring code, you basically will have an operating OpenStack cloud. And as I mentioned before, there are two configuration files that you need to be able to populate information, and those configuration files is what those playbooks will use to actually install and configure your cloud. So I just want to take a minute. I'm going to pop out. I'm going to do something dangerous here, and actually pop right into the StackForge repository and just kind of give you a visual of what those variable files look like. So right here, I'm actually in the StackForge location of the GitHub, and I'm basically just going to go into, so I'm actually going to change the tag. So we'll talk about the tags a little bit later, but I'm just going to jump back to our Juno releases, and because we did actually make gotta love GitHub when you go to do stuff like that. We did make changes in our Kilo release, which will actually be coming the end of this month. So I won't go into those right now. We'll just keep it to Juno for now, which is our current product offering, version 10. So if we kind of take a look at those two variable files, and I'll look at the first one first, which is the easier one, which is the user variables, our YAML file. And what you'll notice in this file is basically a series of users and passwords that you're going to define, so that when it installs those specific infrastructure components or when it installs specific OpenStack services, you'll get to choose and generate what the users or what the passwords may be for those users. So you'll find in here there's a series of variables that you need to provide answers for. Again, there's really no wrong answers in here. It's really up to you. And even part of per the instructions, there's a way of running it where it will auto-generate passwords for you and put it into this file if you didn't have any specific password requirements. So this file is very straightforward. You do have to provide values to each of the variables that are defined here. And that's a key thing. Of course, anything commented out can stay commented out, or you can uncomment it, like in the case if you're going to use LDAP, you would uncomment this block here so that you can leverage LDAP. So it's a very flexible file, and again, this is one of the two variable files that you'll need to give answers to. The second variable file is one that it's a little bit different. I enjoy in this part because this is actually the file that you'll step through that will actually allow you to be able to provide all the answers around the network spaces or the seeder networks you've defined for those bridge containers. Those bridge networks that you'll need to run Neutron, as well as the container networks. You'll be able to determine in this block any set of IPs that you don't want the installer to use. So let's say, for example, if you have bare metal machines and they're going to use the container network of 172.29.236, and you're going to define 1 through 30 to use for the bare metal, you would basically give that range in here in this block so that the OpenStack, the OSAD installer knows not to use those IP addresses when running through the install, because it's going to randomly generate IPs and assign the containers and do things of that nature, as well as assign the IP for the OpenStack services. So that's a very key, important piece of the puzzle. I'm not going to step through this file because it's a lot going on here, but pretty much outside of the starting stanza here, as well as defining the VIP addresses. So this is actually the address of your load balancer, where you're going to have the VIP that'll be your front end to your control plane. You basically provide an internal or external VIP address. If you only have an internal address, no problem. You just put it twice. You have it for the internal and the external. You have the same address. That's certainly no problem. You can do that. Below here, you're pretty much going to leave these blocks, this block here standard. Yes.
Can I ask a question real quick?
Sure.
You go back to the you were talking about the VIPs there for the load balancers. So if you put in if you do the HA proxy piece, how do you know what does this automatically assign the IP addresses? So how would you know what the VIP address for like the HA proxy pieces is actually going to be?
Right. So at the bottom here, you'll see in this stanza here, you actually will tell this configuration file which machine you want to install HA proxy on. And generally, it would either be, you can use so I've seen customers use the control plane server as a HA proxy as well, which kind of gives you a single point of failure, but you could do it. Or if you're going to designate a separate machine as your HA proxy, you would basically give the IP address of that separate machine here, so that the installer will know where your HA proxy is. And the IP address you would use down here for the machine could be the same address used up here for to that HA proxy, kind of like a keep alive. You can configure keep alive to use a virtual address, and that virtual address would be what you would use here for your internal load balancer VIP address. So you can either use the physical machine's address for your HA proxy, or you can give it a virtual IP, but you would have to know it. That would be something you would have to pre-designate ahead of time. Did I answer your question?
Yep, absolutely. Thank you very much.
Okay. All right. No worries. And I know, and slow me down. Tell me if I start to sound crazy when crazy talk, because it gets complicated at times. But it's actually a lot simpler than it actually looks. But yes, you do need to pre-designate that what machine you're going to use as HA proxy ahead of time. So as I was kind of saying, in this whole block here, where it's actually setting up the containers network information, you pretty much can leave this block as is. There really is no reason for you to make changes to this area. All you're going to do is just cause a lot of pain and anguish for yourself. You can then just skip down to the area right below. And in here, this is where it gets very self-explanatory in the sense that you're going to define what machines will be your infrastructure nodes, what machines will be compute nodes, what machines will be storage, sender storage in this example, which machine you would like to use as the logging host, and the same goes which machine you would like to have Neutron running. So I'm going to jump out of here for 1 second and jump into a variable file that has been populated already, because I find that sometimes going off of the example there, it can be kind of hard to follow. So I'm just going to jump into, let's see here. So I'm going to just jump into my repo, my GitHub repo, and pop open a user config that has some stuff in it. So again, I still have a lot of the comments that are listed in here, but this is actually an example of if you were going to deploy RPC using Vagrant that I have out there on my GitHub. And this is the pre-populated user config file that I have there. You'll find that I'm just defining the different seeders that I'm using. I'm telling it what IPs not to use. So my range was only 1 through 20 because obviously with Vagrant it's a very small footprint. I'm defining my internal VIP address, which happens to be the same address as the actual HA proxy node that I'm describing down here below in the config file. Again, I'm defining what node I'm going to use for my infrastructure, which ones I'm going to use for my compute. I'm defining, in this occasion, I'm not doing any sender because it is Vagrant and it's too cumbersome to do on running either VirtualBox or Fusion. I'm defining what machine I'm using for my logger, and I'm defining where I'm going to install Neutron. You'll see that the IP address that I'm designating for Neutron is the same as my control plane. So in this occasion, I'm only running one server as a control plane. So you can combine those functions together. They don't have to actually be separate. We just gave you the opportunity to separate them if that was something you were interested in. So this is a working example of what that config file looks like. And again, it's out on my GitHub. wbentley15 is my username, so feel free to go out there and take a look. I have plenty of other OpenStack Ansible stuff out there as well. So yeah, so kind of getting back to the deck here. So we kind of looked at those two configuration files. Again, they're very straightforward, and that's pretty much what the rest of those playbooks will use to do your install. So wanted to take a minute and actually what I would normally do at this point is actually do the actual full OSAD install right in front of your very eyes. I'm not going to because I fear that the failure factor is very high today, knowing with everything that's been going on. But I can show you the end result of it that I did about 2 days ago. So I'll just jump into that and kind of give you a very quick tour of what that looks like. So, all right. So hopefully you can see my my window here pretty good. All right. So what I'm going to do is what I did prior to joining the webinar is I actually spun up a full-blown OpenStack OSAD install on Rackspace's public cloud. Now, if you tell anybody I did that, I'll deny it through and through, because we would never encourage anybody to do such a thing. But as you can see right here, I have a deployment node, 2 compute nodes, a control plane infrastructure node, a logging node, and I do have a sender node as well. So I'm basically just going to SSH into the deployment node and just kind of take a peek around. So now that I'm in the deployment node, I can basically connect into and using the internal addresses that I defined for the container network and connect to my control plane server. And the reason why I want to do that is because I want to actually get the IP address of the utility container that we have running. And with OSAD, there is a container that is called utility. That container is something you can jump into, and it has every OpenStack CLI already installed. So you can basically administer your whole cloud from within that one container. The reason why that container was created is so that you don't have to feel like you need to jump into any of the other critical containers that are running your services to do the administration. You can connect directly to the utility container, and you'll have everything you need to administer your cloud. So I'm just going to grab that IP there. I'm going to jump back to the deployment host, and I'm just going to SSH into the utility container. So now that I'm on the utility container, I can actually source my OpenRC file that has all the goodies in it. And now if I wanted to do a keystone endpoint list, if I can spell right, wow. It'll pull me back all the endpoints that I have running on this cloud, as well as if I did a services list. It'll show me all the services that I have running in the cloud as well. And if I want to do just a quick health check, yep. So I got some things going on there. I got some resources being used. And, of course, if we want to be really easy about it, we can just jump right into Horizon dashboard as well. And as you can see, this is the same IP address that I use for the deployment node, the same public address. And we can actually log right into Horizon and poke around and take a look at some things. So you can see this is a functioning OpenStack cloud. And if we go look at hypervisors, we look in compute hosts, you'll see that they are up and running. If we want to look at the system information, we'll see that we have all the network agents up and running, and the services are ready to go, all running against that same internal VIP address that I have designated for the HA proxy. So my deployment node is actually my HA proxy node in this situation. And anyway, you guys have seen Horizon before, so I can go on and on. But this is a working example of what you probably saw up above when I jumped into the infrastructure node. You'll see that I was able to do a LXC-LS-fancy, and it actually listed out all of the OpenStack containers that are running on that machine. And this is the format that it'll show in. So if I wanted to do something with Galera, I could jump into the Galera container. If I needed to do something with Nova Scheduler, I can jump into the Nova Scheduler container just as well. So just wanted to kind of briefly show that. Again, I didn't show the full power because I usually do the install right in front of you, but I don't want to torture you guys any further. So I always like to at least try to end off with sharing some tips and tricks around dealing with OSAD. As simple as it is, it can be complicated at times. So, these are just some of the things that I've found to help make that experience a lot easier. So the first tip that I would give anyone who's going to use OSAD or look at OSAD is deploy using tags, the tag versions in the GitHub repo. And what I mean by that is that instead of getting back into the StackForge repo, so instead of just doing it from master, or well, let's get back to the actual OpenStack repo. One more. So instead of just either using the master branch or using, I'm still not there. Sorry, wrong browser. Moving too fast. There we go. So instead of just using the master branches, whether it be Icehouse, Juno, Kilo, or Master, which you could very well use, I found that I had more success with using the tags, which are sitting right here next to it, and deploy using the tags because you'll know exactly which release you're pushing out. This is a continuous build process that they use with OSAD, so as they make additional changes to code, it is actually continuously released out here to GitHub. So if you don't go after a specific tag that you know is working or a specific tag that is not the newest, you have a higher success rate. If you go after the newest one, which I know is very tempting to do, you may run into a situation where there may be a bug in the code, and you'll think that it's you, and it's actually not you. So what I generally do is I generally try to stay within the current release, major release versions. Right now, the current major release version is version 10.1.10. So that's generally what I would stay with. If you're feeling very risque that day, you can go after the 11.0.3 or 2, which would be considered Kilo, if you wanted to go after that. But if you start running into issues, go back to an older tag, a previous major release version tag, and I'm pretty sure you'll have better success. So that's the first thing that I would suggest. As I mentioned before, go for newer versions, and also make sure that they have not introduced any new variables. Part of this process and part of it is that we do make improvements to it and changes sometimes to the next change in the way the Ansible playbooks are structured as far as the variables and how they're presented. So you definitely have to go and check back to the GitHub repo whenever a new version is released, and make sure that your biggest tips that I can provide is triple check your network setup. I find that 99% of the failures of OSAD installations are around the fact that networking components weren't set up accurately. So triple check make sure all your bridges, test them, make sure everything is working. Redeploy. If you run into a situation and or your friend, it will save you countless hours of trying to rerun the playbooks against your whole cloud again, because it's just unnecessary. Again, I did speak about a lot of ref materials. Some of the ref materials that I spoke about was the actual installation guide, which is found at this link here. The OSAD installation guide can be found here, and you can go here, and it's diagrams and pretty pictures and 72 pages of explanation as to how to do the OSAD installs, as well as there's a link here to a blog that I did around deploying RPC using Ansible, and that's some of the stuff I showed you on GitHub about how you can deploy OSAD with Vagrant, and this blog post was inspired by that. So feel free to check that out if you want to read some of my words around doing the OSAD deployment using Vagrant. And that is it. Hopefully this wasn't too much of a train wreck and you will be able to take away something from this. My Twitter information and email is listed here. Feel free to, any one of you guys to reach out to me with any question, comments, or concerns. I'm here to help, but I'm definitely here now and available to answer any questions you may have.
Awesome. Thanks so much, Walter. And yeah, I actually just lost my connection for about the last 2 minutes, so I've been trying to get back in. So, but yeah, thanks so much. And yeah, are there any questions out there before we kind of wrap it up? And we'll give it a second. Check Twitter. I'm not seeing anything out there on Twitter yet. And
so either I did a fantastic job or they hated it.
No. You did do a fantastic job. I think it was great. We had some audio issues. That's not a big deal. You deal with that all the time. But yeah, I think that was terrific. Thanks so much, Walter. And oh wait, do we have a question here? Ansible, do you ever use Tower?
So that's a very popular question that I'm asked. So Tower for Ansible is actually a really great tool to give to those who may not be tech savvy. So imagine the fact that you're a DevOps engineer and you go off and create a series of playbooks and roles, and you want your users or your consumers to be able to execute those, but you don't want them to have too much control, meaning you don't want them to have access directly to your machines, but you want them to be able to execute those playbooks. With that situation, Tower is a perfect tool for that, because within Tower, you actually store the playbooks on your Tower server in a place that the users can't get to them, but they can execute them as well as populate information as far as variables that need to be passed to the playbook that's being run. They can do that all from a GUI interface using Tower. So with OSAD, it's really not necessary, because OSAD is pretty much something that you would probably do just to build your cloud. You probably wouldn't give those playbooks to someone to execute over and over again. But if you're going to go outside and create your own Ansible playbooks and you want to give those to, let's say, a QA engineer, or give those to a developer so that he can build an environment over and over again, Tower is a perfect tool for that.
Sweet. All right. Any other questions out there? I think we're good. We'll go ahead and wrap it up. Again, thanks to you, Walter, and thanks to Jeff for co-hosting and tweeting, and hopefully, Walter, we'll get you back on and talk more about OpenStack and Ansible.
Yes, I would love that, and I promise next time around my audio will be great, and I will be early, not just on time.
No worries, man. All right, well, thanks to all our listeners out there, and we'll catch you next week.
Take care, guys.
Thanks, guys.